Now let's look at a set of examples. Let's focus our attention on the first set of ordered pairs, we have to identify whether this is a function or a mere relation. So how to check? Again, the idea is one value of x in the domain should be paired to a single value of y which is in the range. If we are going to inspect every pair, the first pair says 1 is paired to 1. The second pair says 1 is paired to negative 1. So that means 1 is also mapped to negative 1. And this is already violating the idea of a function because a single value in x or a single value in the domain is giving us more than one value in the y. That is 1 to 1 and then 1 to negative 1. Therefore, the first relation is a mere relation and not a function. In the diagram, if we are going to check every element in the input, say let's start with 0, the line says 0 is paired to negative 2 and 0 is also paired to positive 1. And that is already a violation in the definition of a function because 0 is paired to more than one value in the output. Again, this is a mere relation, or we say this is not a function. In the third one, for the graph, if we select, say, an x is equal to 2, so this is how we see what are the values that correspond to the x equals 2. To do that, all we have to do is to trace the graph from the value x equals 2. That means if x is equal to 2, we go to the graph and it says there is one possible value of y that corresponds to that x equals 2. However, if we go down to the other part of the graph, there's also another y value in which x equals 2 is being paired. And that also is a violation for the definition because x equals 2 is paired to more than one value of y. In other references, when a relation is given as a graph, they use a test we call the vertical line test. The vertical line test is done by creating a vertical line to pass through the graph, and then for it to be a function, there should be only one intersection. Now, as we can see from the line that I have created, the line intersected the graph at this point and also intersected at this point. So it does not intersect at a single value in the graph. Therefore, it fails the vertical line test, and this shows that the relation is a mere relation and not a function. Now let's consider the second set. If we focus our attention on the set of ordered pairs, we can see that 1 is paired to 1 for 1, 1, 2 is paired to 4 for 2, 4, 3 is paired to 9 for 3, 9, and 4 is paired to 16. If we take a look at every x, each of them is only paired to a single value in y. Therefore, this relation is an example of a function. In the same way, if we look at the map or the diagram mapping the values in x and y, 2 is being paired to 4, that's a single value. 2 is being paired to 4, that's also a single value. Please do not be confused thinking that 4 came from or is paired up to two values of x. Remember, the rule is from x to y and not y to x. So this is not our rule. To check, we always check from x to the corresponding value of y. So even if two x values shared the same value in y, or the same value of y, it doesn't mean that it will no longer be a function. What we need to check is from a single x, how many y values is paired to that x. Okay? If we continue, 4 is to 16, a single value, 5 is to 25, and 6 is to 36. Okay? So, as we can see, if we base or we inspect a diagram, we could see two types of situation. Is that one value of y is paired to a single value of one value in x rather is paired to a single value in y, or there are many values of x being paired to a single value in y. Now both of these cases will be valid for functions. Okay, the last one is the graph. Since we learned the vertical line test in the previous example, so how we use the vertical line test is, again, create a random vertical line anywhere in the graph, and if we can be confident that each line will only intersect at a single point, then that means a relation is a function. And clearly, this graph shows that the function, or the relation rather, being described is an example of a function. Okay, so that's the basic idea of a function. A function is a relation where each element in the domain is related to only one value in the range by some rule. Okay? Now, lastly, to emphasize that relationship, a function is just an example of a relation, meaning to say that all functions are relations. But we cannot say, so the statement all functions are relations is correct, but the reverse is not correct. We cannot say that all relations are functions, because as we can see in the diagram, there are relations outside the set of functions, and these relations are what we call mere relations. Okay, so I hope you learned from this video. This is focused more on the basic idea, the fundamental idea on how to identify a function from a mere relation. Always keep in mind the defining characteristic of a function is that one value in x is just paired to a single value in y.